All right, so this week we're going to take a look at word problems. Pretty much doing the same kind of thing we did 2 weeks ago. We're going to solve equations. We're going to use substitution. I mean, you could use elimination, but I think substitution is going to be easier for the kind of problems we're going to be using. All right, so system of equations. Okay, just quick review of that. When you're solving a system, what does that mean? Like how many equations do you usually have? Think about what we did in the warm-up. How many equations do you have in a system? Yeah? 2 equations. And how many letters do you usually have to solve for? Yeah. 2. Okay? You have 2 equations, and you have 2 variables. Now, when you guys take, when you get to like algebra 2, it doesn't always have to be 2 equations. Sometimes it could be 3 equations. You know, it could be 4 equations. Generally, they don't have you do more than that by hand. But in this class, we always do 2.
We use like the variables of what problem gives us, or we always use X and Y.
We're going to use the variables for what they give us, because it'll make more sense. If it said like Bill is twice as old as John, I would use B for Bill and use J for John, because that's going to make more sense. Because if you use X and Y, then you got to try to remember, wait, X was Bill and Y was, just use the letter for the person. The only thing that would be a little tricky is if you had a person's name that began with like an O, like Oliver. O could be kind of confused with 0, so that's probably not a good letter to use. Maybe you'd want to use L, because it's the next letter in the word Oliver. But yeah, don't use a letter that looks like a number. All right, so an example of a system. What letters do we normally use if it's not a word problem?
X and Y.
X and Y. All right. There's an example of an equation that could be part of a system. Now, Dave, if that's part of a system, how many more equations do I need? At least. At least 1 more. And I could have more, but we don't in this class. Can you give me 1 more equation?
Y equals 2x minus 4.
Perfect. Now, the equation that Dave just gave me, y equals 2x minus 4, I would say based on what he just said, this is set up for substitution.
Yes, sir.
What am I looking at here that tells me this is probably ready for substitution? Versus what we did last week. When you're doing substitution, you always look for what? And we did this in the first problem on the warm-up. Yep. Right, look for a letter that's by itself, right? And that's usually what's going to happen this week. You got a letter all by itself on one side of the equal sign, right? You got that same letter up here. So we can use substitution and plug in. Now, you could do elimination. We did elimination like this last week. We had to rearrange it and get the X's and the Y's on the same side, but we're gonna stick with what we did in the warm-up. All right, so what are the 3 methods that we've used for solving systems? Anybody remember the very first one? We didn't like this one as much.
It involved that y equals mx plus b. It was more visual than anything else.
Yeah. We did graphing, right? We talked about all the reasons why graphing's not the best. Sometimes you need a ruler, you got to draw things accurate. If your answer's a fraction, you can't really tell that unless you graph it on a calculator, but by hand, that's kind of tough. So we did graphing. What was the method we did after graphing that we just practiced in the warm-up? What was that one called? Yep. Then we did substitution. And what was the method we did last week where we try to get things to disappear? It ends with an E. We did elimination. Yep. I would say either one of these 2, those are usually pretty good ways to solve systems. Graphing, it gets kind of hard, right? Especially when you graph things, if you had to do like 3D. If you had to solve something with 3 variables, it's not that much different with substitution than what you're doing right now. But graphing, yeah, it would be. Because graphing, if you had 3 variables, you'd have to draw 3-dimensionally. That's really hard by hand. Okay. All right, so we're going to solve 2 types of systems word problems this week. The first type we're going to look at is age word problems. Again, what's kind of nice about these is your answers usually aren't decimals. Right? You're solving for someone's age, so you're going to get nice answers. Tomorrow, we're going to do mixture word problems. You can get some decimals there. It depends on the problem. Right? But that's it. Those are the only 2 types we're going to look at this week. And then we'll talk more at the end of class about the test and what you can use on that this week. All right. All right, so when we do age problems, we went through those words like is, was, will be. What did we say those all mean? They're just the past, and the present, and the future form of what symbol? Yeah? Yeah, they all mean equals. So pretty much every problem that we do today is going to tell you something about somebody's age now, and then something about their age in the future. Okay? Or it could be the past. Depends. All right? So this is a problem that's asking you to write down an expression about someone's age in the future. Okay? 6 years from now. All right? So it says, let t equal Tim's age. Okay, t, perfect variable because we're dealing with Tim. Write an equation that represents Tim's age 6 years from now. All right. So right now, Tim is t years old. What would you have to do to t to get his age in 6 years? Think about what you would have to...
What operation would that be? His age in 6 years.
Like if you knew his age now, what calculation could you do to get his age 6 years from now? Addition. And how much would you add?
6.
6, exactly. So this, it's not a problem you can solve, right? We don't actually know Tim's age right now. We don't have enough information. But if you wanted to know Tim's age 6 years from now, that's what you would write,
yeah.
t plus 6.
Because guys, you're going to see, in these problems, you're going to, obviously we're going to have to figure out their age, their present age, or their current age, but then it's going to ask you to either figure out their age in the future, so in this case, 6 years from now, right? That's how you would express it. Or it'll also ask you maybe find it in the past. And we'll talk about that right now.
So how do you know this one is in the past? Like what phrase there gives it away that it's before now? It's in the past.
Years ago.
Years ago. Right? And when we did the warm-up, I think we did that one. Years ago, you would subtract. Okay? So we always start with their age right now. Okay? T. Now, if you wanted to know Tim's age 4 years ago, what would you do with his age now? What? You would subtract. And how much would you subtract?
4.
4. Okay, and again, when we do a problem, there's going to be a second person involved, right? So maybe it'll say something like, Tim is twice as old as Mary, right? And then 4 years ago, you know, it'll tell you something else, all right? So you're going to have a little more information than just that. Okay, so any questions on the idea that an age in the future means to add versus in the past means subtract? All right, so another very similar one. Let R equal Ryan's age now. How old will Ryan be in 4 years? Okay,
Yeah, we don't have to figure it out. We just want to be able to express it or represent it.
so right now, Ryan is R. How would you get his age 4 years in the future? What would be the calculation? Let's see. Exactly, R plus 4. All right. How about how old was Ryan 8 years ago? Right now, Ryan is R. How would you find his age 8 years in the past? Yep. R minus 8. Perfect. All right. Little more complicated, right? A little bit more stuff going on. How would we represent twice Ryan's age 7 years from now? All right, so there's a couple things going on. Twice Ryan's age. Let's just start with that. How would you take Ryan's age and represent twice Ryan's age? What operation would you have to do that means twice? Multiplication. And twice means how many times? Like 2.
So R times.
Times what? R times 2. Yep. Or you can put 2 times R. Same thing. We usually, when we have to multiply something, we put the number in front, then we put the letter right after. So what you've got right now is this. Twice Ryan's age. But it doesn't just say twice his age. It says twice Ryan's age 7 years from now. So what does that mean when you do 7 years from now?
You gotta add 7.
You have to add a 7. And we're going to talk about this, but that's how you have to do it. Right? You always have to put what their age will be or what their age was in parentheses. Always. Okay? And the template's going to help you do that. But you always have to put how old they are going to be or how old they were in the past in parentheses. Always.
So then like multiply that.
Right, and then it's almost like it would be like a distributive property. Exactly. That's what's going to happen in pretty much every problem. You're going to have a distributive property because you have to put their age in parentheses. Okay, but we'll talk about that again in the template. But it's a little tricky. All right, let's try one more like that. How would we represent 4 times Ryan's age 3 years ago? So let's start with this part. Ryan's age 3 years ago. What would that be? Yep.
R minus 3.
R minus 3. And what did I just say you always have to put it in?
Parentheses.
I'm going to put it in parentheses. So that block of stuff right there, that's Ryan's age 3 years ago. Now they want 4 times that. So what would you put on the outside of those parentheses that's going to end up being distributed?
4.
Exactly. Yep. That's how it's going to work every time. Parentheses, person's maybe a 4 or some number on the outside. Okay, so any questions on that? Ryan's age 3 years ago, and then 4 times it on the outside. All right. Okay, so Mr. Roy is going to go through with kind of how you set this up. Like each column is always going to mean something about the person's ages. So we'll let him take a look at that.
You guys, tomorrow when Mr. Hager said we'll do like those mixture word problems tomorrow, we'll use the same template. But for today, like what says name, like whatever person's name they're talking about in the problem, we'll put them there. And like Mr. Hager said too, we'll usually, like people ask if we're going to use X and Y or whatever. For this, if we can, 90% of the time, we're just going to use the first letter of that person's name to represent them. That way there's no confusion, like who was X, who was Y. So we'll just use the first letter of their name. All right? This first row, all right? So whoever the person is, we'll say, you don't have to write this down, I'm just showing you. Joe and Harry. All right? So usually in this first row, all right, we're just going to represent Joe as J. Oops.
What is it?
What happened there?
It's Dave.
No, I'm just giving you an example. I'm just showing you guys how it works. All right? So we will represent Joe as J and Harry as H. Usually, the first sentence in the word problem you're given is going to be This first row is usually dealing with the present. This second row usually deals with the past or the future. It'll say like years ago or in a number of years. That's how you know whether it's the past or the future. If it's past, I want to subtract. If it's future, I want to add. All right? And it all depends on how many years ago, how many in whatever number of years. It all depends how it's set up. If it said like in 4 years, I would add, right? So it would be J plus 4, H plus 4. So to set up my first equation, it's usually the first sentence of the word problem. So if I saw Joe, wherever I saw Joe, I'd put a J. That's how I'd represent it. Wherever I saw Harry, I'd put an H. For my second sentence, whether it's talking about the past or the future, all depends on how it's worded. If I see Joe in that second sentence, instead of representing him as J, I'm going to represent him as J plus 4. Because now I want to know the future. Same thing for Harry. If I'm talking about Harry in 4 years, I'm going to represent him as H plus 4, not just H. All right? Most of the time, like Mr. Hager said, we're going to use substitution because one of the variables is already going to be isolated. It'll be by itself on the left-hand side of the equal sign. We're going to deal with some that say the sum of their ages is 72, whatever. If it's a sum of their ages, then you would have to rearrange to get one of the variables by itself. It'll make more sense when we do it. All right? So this is, again, like I said, it'll make more sense when we actually do an example. All right, so first example. Now, guys, I know this has some arrows coming out of it. Don't worry. I was going to kind of write everything out to explain to you, but I think that's going to confuse you more. So we're just going to work right through the problem so you can see. Now, on the test this week, kind of like last week's test where we did the elimination and we gave you guys credit for setting up equation 1 and equation 2, we're going to give you credit for being able to look at the word problem and being able to set up the equations. So even if you don't get the right answer, if you set it up correctly, you're still going to get some points. So if you make a mistake with your arithmetic, you're still going to get some points if you set up the equations correctly. All right? So here we have Joe is 4 years younger than Dave. That's my first sentence. So, for my names, right? Miguel, what's one name I'm going to write? Joe. So in the name column, I'm going to put Joe. And how about Alex? What's my other age? My other name? Dave. Again, that's all I'm going to do that's all I do for names. Write down their names. Now in that first sentence, am I talking about Joe and Dave presently, in the present, in the future, or in the past? Am I talking about them and their ages in the present right now, in the future, or in the past? Present, right? So how would I represent Joe? What do you think, Paige? How would I represent Joe? What letter do I want to use? J. Again, it's talking about the present. 90% of the time, guys, that first sentence is going to deal with their ages in the present. So Joe would be J, Dave's going to be what? D. All right? So now I know how I'm representing them. Now I'm going to go back and read the sentence, and I'm going to take it from actual written words and put it into an algebraic expression. Based on, I'm going to look at, again, where I see Joe, I'm going to put a J for my first equation. Where I see Joe, I'm going to put a J. Where I see Dave, I'm going to put a D. I already know how I'm going to represent them. And I'm just going to look back at that sentence and see where their names are. I'm going to put those letters. Think back, think about the warm-up. All those little words we talked about. Is, was, will be, some. Those things are important now because you have to be able to take them written in English and be able to translate them into algebra. All right? So we're going to look at that first sentence. First thing written there is Joe, right? And we know where we see Joe, what are we going to put? What letter?
J.
J. It says Joe. I'm representing in my expression. I'm representing Joe as J. So in the little circle here, I'm going to put J. Joe. What's the next word?
Dave.
Huh? No. What's the next word written?
Oh, 4
Nope.
Is
Is. What does is mean, Ellie?
multiplication.
Nope. Someone help us? Jake? Nice job, right? Look it. We already have it there. Joe is. J, again, taking it from English and translating it. Joe is J. Is equal. 4 years younger than Dave. When we go to this next part, my suggestion would be put the variable first. Put the variable before the addition and subtraction. So what's my next variable going to be in this equation? What letter? Someone raise their hand and tell me. Matt? D for Dave. I've already taken care of Joe. I've already taken care of is. I've already taken care of Dave. There's only one more phrase in that first sentence that's important to me. What is it? Is there a number there? Allie?
4 years younger.
So what's the number?
4.
4. I'm going to put 4 there. The only thing I have to decide now is what operation is going to show 4 years younger than. Jake? Not sure? Okay, Savannah?
I got it.
Huh? Subtraction. When it's younger, it's subtraction. Right? To get the difference between my age and Jake's age, I'm older than Jake, we're going to have to subtract. He's young, Jake's younger than me, we have to subtract. It's minus. Remember, younger than is subtraction. If it's older, it's addition. Alright? There's your first equation. So where it says equation 1, you can fill it in now. J equals D minus 4. So you get, what would they get, Mr. Hager? A quarter. If the question is worth 4 points, you'd have a point.
Yeah, like Mr. White said, you get a quarter of the points for each part. Yeah.
So there's your first equation. Now, usually that second sentence is going to tell you whether it's the future or if it's the past. So in this particular problem, what are we talking about? Are we talking about the future or are we talking about the past? What do you think, Dylan? Based on what it says at the beginning of that next sentence, are we talking about the future or are we talking about the past? The past, right? 10 years ago. How do I express that? What operation? If it's 10 years ago. Minus, you're right. Minus what number? 10. In this the second row, right? I'm going to put at the top, my heading is going to be whatever it is. Am I talking about the past? Am I talking about the future? Like Dylan just told us, we're talking about the past. He said minus 10. So like we just did in the little practice we did before this. Now I want to represent Joe. I want to represent Joe in 10 years. So what do I write? If I want to represent Joe in 10 years ago, how do I do that? What would I write? Joe 10 years ago. I'm not solving. I just want to be able to express how to do that. Joe 10 years ago. What do I write? We already did it a couple times in the previous ones, right? 8 years ago was R minus 8. Keep that in mind. So now I want to know Joe 10 years ago. Donovan?
J minus 10.
J minus 10. How about Dave 10 years ago? Ellie?
D minus 10.
D minus 10. Now just like in the first equation, When I saw Joe, when I read the problem, right? Where I saw Joe, I put J. Where I saw Dave, I put D. Now we're talking about the past. So when I read that second sentence, when I see Joe or he or something like that, I'm going to represent it as J minus 10 now, because I'm talking about the past. Same thing with Dave. Dave is going to be D minus 10.
Victoria, you want to put parentheses around it now?
Around what?
The D minus 10 and J minus 10? So we
We
remember to always keep them there?
We can. So we got 10 years ago. We already covered that. Not important anymore because we already put the minus 10. So we already did that. First thing, after it says 10 years ago, what's the first thing that we see? Ellie?
Dave was 3 times.
Dave, stop. Dave. How am I representing Dave?
D.
In the present, it was D, but now I'm talking about 10 years ago. How am I representing Dave 10 years ago? D minus 10. Again, all you're going to do is look at when you're setting up your equation. The equation you set up in this box, look at the boxes on top of it to see how you're representing that person. It says Dave. I look at Dave. I'm representing Dave as D minus 10. Covered Dave. What's the next word after Dave? Ellie?
Was 3 times.
Was. The next word, not words, words. One word. Was. Jake, you got is, was, will be, all mean equal. Nice job, buddy. Was. Took care of it. It's gone now. Next thing is what, Yusuf?
3 times, right?
3. Right? So if it's a number, we're going to write that number. 3. Got it. After the 3 is what? Mary.
3
After the 3 is what word?
of time.
Excuse me. Alright, so what am I going to do to represent times? Alright, so what are some ways I can express multiplication? I could use an X, I could use a dot. What else could I use? Parentheses. I'm going to stop my parentheses. It says times. Done. Oops. Whoa. As old as, I'm not worried about that. After it says as old as, it says what? Ellie?
Joe.
Joe. Am I talking about Joe as a J? Am I talking about Joe as J minus 10?
J minus 10.
Yes, I'm talking about the past, right? I'm dealing with the stuff in this row. Equation 1 is done. I'm not gonna need it. I'm not gonna need it right now. So it's D minus J minus 10, right? And my parentheses. Use these variables for the first equation. Use these. Use this information to represent these people in the second equation, or the past or the future. Use these variables to represent these people in the first sentence. You're just looking at what's up here. It says Dave. All right, so it's the first equation. If I look at Dave, it says D. That's how I represent. All right, all the stuff here is representing these people in the first equation. All the stuff here is representing those people in the second equation. That's how it works. Now it's just going to be substitution. All right? And it kind of gives you some tips. Let me scroll down. I'm going to scroll down a little bit. Okay. So now it says work area to solve using substitution. It says I'm going to write the row 2 equation with parentheses around for the circle. So that means whatever letter is in the circle here, I'm substituting this information for that letter in the other equation. Let me say it again. I'm going to take this information and write it in for that letter in the other equation. So I'm going to write D minus 4 for J in the other equation, in the row 2 equation. So where I see J, he's going to put green around the J over there. And I'm going to draw an arrow too so you can see. Everything else stays the same. The only thing that changes is the j becomes d minus 4. Everything else stays the same. So I'm going to start, I'm always going to be substituting the row 1 equation into the row 2 equation. It's always going to work that way. In this case, I already had a variable by itself, so I do not have to rearrange. It's already done. All right? So I'm going to get d minus 10. Again, it's all part of the first equation, row 2 equation, equals 3. Stop my parentheses. What am I going to write? Ellie?
D minus 4.
D minus 4. What's the rest of it going to be, Ellie?
Minus 10.
Minus 10. And my parentheses. All right? Now when I get here, I got to look and see, are there any terms inside the parentheses that I can combine? Any terms inside?
Could you do -4 and -10?
I can do -4, -10. What do I get? I'm going to keep the sign. I'm going to add those numbers together.
-14.
-14. Bring my d down. All right? What am I going to do now? I'll give you a hint. It has something to do with those parentheses. Ellie?
Distribute 3 to D and do -14.
Nice. I didn't do anything on this side. Bethany, 3 times D? No, 3 times D. So what's 3 times 1? 3, right? So when it's like this, when I have a single variable on the inside with a number on the outside, just smush them together.
Mr. Royce,
3D.
like 3D.
Yeah, 3D. All right, and then I'm going to take calculator.
42.
42. Negative 42. All right? Again, net positive times a negative is a negative. All right? Now we got some choices. We can either move the numbers with no variables attached, or we can move the numbers that have the variables attached. It doesn't matter. Ellie?
Wouldn't it make more sense to move the numbers without the variables?
You can do that. So what do you want to move first?
-10.
And how are we going to do that?
So you plus 10 on both sides.
Add 10 on both sides.
Plus 10 and then plus 10.
I didn't use the D, I'm just bringing it down. This cancels out, equals.
3D.
So this means which line is bigger? I mean, which number is bigger, 42 or 10? Ignore the signs. Which number is bigger, Garrett?
I'm sorry.
Which number is bigger? Ignore the signs.
Oh, 42.
42. 42 is negative, right? I keep the sign. 42 minus 10 is going to be what, Garrett?
-32.
Negative 32. So because I moved the numbers first, all right, I have to move the letters now. So what number am I going to move? What number or letter am I going to move right now, Ellie?
D.
Well, if I move the D over here, everything's going to be on one side of the equal sign. It won't be balanced.
Could you put a 1D in front of the...
I can do that, but it's still not going to change.
Alright.
And there's only one option now in terms of where I can move something. What do you think, Mary?
You can move the 3D over to the other
How do I do that?
fraction.
Minus 3D, minus 3D. I'm going to end up getting a negative 2D here. Equals negative 32. All right? Brady, last step. Division. You know what I'm going to divide by?
No, I'm not sure.
Not sure? Ellie?
-2.
Divide by negative 2. D equals, anybody know? Is it going to be positive or negative?
Negative.
It's going to be positive or negative, Savannah? Positive. We're doing negative divided by a negative, right? It'd be positive. It's going to end up being 16. So Dave's age is 16. All right? Dave's age is going to be 16. So now it says, again, and this stuff will be written on even on the template you get in the test on this week. This will be written on here. Substitute the letter you solve for. So we just solved for D. We're going to substitute 16 in for D in our row 1 equation. So our row 1 equation was, someone tell me, what's our row 1 equation? Ellie?
J equals 16 minus 4.
I'm gonna write D minus 4 first so you guys can see it. 4, not 14. Alright, and Ellie just said, again, substitute, it says substitute the letter you solve for. We just solved for D. D is 16. So instead of D, I'm gonna write 16 minus 4. Alright, again, I always want to put, it's always gonna work out this way because this variable is always gonna be by itself. Then you can just do the arithmetic on the right hand side. J equals 16 minus 4 is what, guys? 16, 12. So, I'm going to scroll back up.
So Joe's 12 and Dave's
Yeah. So it says Joe, I'm going to put 12. Where it says Dave, I'm going to put 16. My row 2 equation was this. Or equation 2. D minus 10 equals 3J minus 10. So on the test, you're going to have to take your row 1 equation and write it for equation 1. You're going to have to take your row 2 equation, write it for equation 2. Then when you get your answers, you have to write it in. So even if you do make a mistake with the arithmetic, but you set up your equations correctly, you'll still get half credit.
Because then it adds up to Joe being 4 years younger than Dave.
So it all works out.
Yeah.
And again, down here, if you're doing it and you get a negative age, then you know you did something wrong. Because age can't be negative. It's always going to be positive. All right? So that's one example. So that dealt with one in the past. We may deal with one in the we may deal with one when we're talking about future ages too. All right? So that's how that works. Next one.
You skipping 2?
See 2. Yeah, it doesn't matter. They're kind of the same thing anyway. Guys, we'll go to 3. If we have time, we'll do 2. All right? Now this one's a little bit different because look at it. It says before we even do that, what are our names going to be? Someone tell me what our names going to be. Allie?
Megan and Jackie.
Mm-hmm. So Megan here. Megan was the first name I saw. I read it in the first box for a name. Jackie was the second name I saw. I'll write Jackie second.
So then the variable would be M and
Now hold on. So I'm saying you're on the right track, Ellie, but be careful. This one's a little bit tricky. All right? In 3 years, Megan will be 5 times as old as Jackie will be. Usually, that first sentence deals with the present. What about this one?
deals with the future.
The first sentence is dealing with the future. So which row deals, when we're solving these and filling in our template, our chart here, which row usually deals with the present, which row usually deals with the future or the past? Row 1 or row 2? Row 2, right, Nicole? All right, so we're going to put the first sentence is actually going to be the information for row 2. Because row 2 is either going to be the past or the future. This works out easier that way. It's the way the template's set up. All right, so in 3 years. So what does that mean I'm doing? What operation? If it's in 3 years, what's happening? Ellie?
Adding.
Add what number?
M plus 3.
Yeah, so I'm going to put plus 3 here. I put that plus 3 because it tells me whatever my single variables are, I'm going to add 3 to it. All right? So how will we represent Megan? As what letter?
M.
M. And Jackie would be J. All I'm doing here for my future or my past, I'm taking the single variable, either adding a number to it or subtracting a number. And it all depends on if it's the past or the future. So this one will be M plus 3. And the bottom one will be J plus 3. Again, it's a little bit different because my first sentence is dealing with the future. Usually it's the other way around. Usually it's the second sentence that talks about the future or the past. This one's just a little bit different. Alright? So again, in this first sentence, wherever I see Megan, I'm representing her, I'm expressing her as m plus 3. Wherever I see Jackie in that first sentence, I'm going to represent her as j plus 3. Alright? So let's look at it. In 3 years. Already took care of it. Ellie?
So it says Megan. Well, wouldn't that mean it's m equals?
Not m equals. Again, the first sentence deals with the future. Usually it's the second sentence, but in this case it's the first sentence. So we're filling out row 2 right now. So we see Megan first. So what are we gonna write? M plus 3. So we're talking about in 3 years. So it's gonna be where I see Megan, it's gonna be m plus 3. Megan, gone. Jake, will be. What's it mean?
Equal.
Is, was, will be, all mean equal. So will be, again, I'm just going through piece by piece. Again, in 3 years it said. So I know I'm dealing with the present. Megan in the present is m plus 3. I just wrote that. Will be is equals. I just wrote that. I don't need that. Melanie, what's the next thing I'm going to write?
5.
5. It says 5. It says the number 5. Let's write it. After the 5, Melanie, you think you know what we're going to write? So I got the 5.
Times, which is multiplication, so you would put parentheses.
I'd stop my parentheses. Good. 5 times is old. I don't care about that. I don't care about that. Then I get the Jackie. Nathan, what am I going to write for Jackie? We're talking about Jackie in 3 years, not Jackie in the present, Jackie in the future. So if you're not sure, look at the boxes above it and see how we're representing Jackie.
3
So what am I going to write?
plus 3.
1 plus 3.
J plus 3.
J plus 3. That's Jackie. Jackie in 3 years is J plus 3. And my parentheses. All right, again, this one's a little bit different because the first sentence dealt with the past or future. In this case, it was the future. We already know Megan and Jackie, M and J. All right? Now we're going to set up our row 1 equation, which is them in the present. So it says the sum of their ages. What does that mean? When we talk about sum, what operation are we using? Ellie?
Wouldn't that be equals?
No, it will equal something. But is it addition, subtraction, multiplication, or division? I see the word sum. What does that mean? What do you think, David? Add, subtract, multiply, or divide?
Addition.
Addition, right? So, I gotta be careful now. When it says the sum of their ages, you're gonna have to rearrange to get one of the variables by itself to be able to substitute. So on your thing, it might say line up or line up if necessary. That means you have to rearrange it to be able to plug it in. So I'm not gonna, when it says sum of their ages, I'm not gonna go ahead and write the circle, write the variable in the circle right away. I can't. So like David just said, it's gonna be plus the sum of their ages. So what 2 things am I adding together? How am I representing Megan and Jackie in the present? Kelly?
M plus 3.
M, okay. I like M because Megan in the present is M. Plus, what's Jackie in the present?
J.
J. The sum of their ages. Again, in the present, Megan is M, Jackie is J. Is, let's scroll back up. What number am I going to write? Sum of their ages is what? 78. Now, we can't use substitution right now because why?
Because there's something to substitute.
Yeah, one of the variables isn't by itself. I have to have a variable by itself to be able to do substitution. So what do I need to do to get one of those variables by themselves? Do you know, Joe? To be able to get one of those variables by itself. Like if I wanted to say m equals, what do I have to do? I gotta move something. Subtract what? So I want to get m by itself. So what do I do? Subtract j. So I'm going to go minus j. It'll make it m equals 78 minus j. So if it's in the problem, if it says the sum of their ages, you cannot just go ahead and be able to substitute it. You have to rearrange it. You have to get one of the variables by itself to be able to plug it in. All right? Now we can substitute. Okay. All right. So again, what letter am I substituting for in the row 2 equation? What variable is going to change? What variable am I going to plug stuff in for? Gigi? M, right? Whatever letter is in the circle, you're going to plug in this information for that letter in the other equation. So I'm taking the 78 minus j. Now, sorry, mistake. Go ahead, buddy. I'm taking the 78 minus j and I'm plugging it in for m. Let me scroll down a little bit. Somebody tell me what to write. We got the stuff highlighted. What am I going to write now? Ellie?
78 minus j plus 3 equals 5, comma, or parentheses j plus 3.
Perfect. 78 minus j plus 3 equals 5j plus 3. Let me say it again. I'm taking whatever variable is in the circle. Take this information that's inside the parentheses, plug it in for this letter in the other equation. So this blue is now becoming that. Now it's all set up. Now for this to be consistent, let's distribute first. What number am I distributing? 5. Good, Gigi. So nothing changes over here yet. 78 minus j plus 3 equals, when I distribute the 5, Miguel, what am I going to get?
5j.
5j, good.
15.
Plus 15. So I just did that. So I just distributed. What can I do next on the left-hand side? Anybody see? Ellie?
Could you subtract j from both sides?
Nope, not yet. What can I do on that left-hand side? Savannah? What am I combining? 78 and 3, a positive 3, is going to give me 81. 81 minus j equals 5j plus 15. I got options now. I can either move the variable, or I can either move the numbers that have letters attached, or I can just move the plain old numbers. It doesn't matter. What do you want to move first, Yusuf? Doesn't matter.
Let's just move the j.
Move the j. How do I do that?
Plus.
Add j. What do I add on the other side?
J.
To the 5j, right?
Yeah.
What do I say it again? What do I get when I do that? 5j and j. 6j. 81 stays. I did nothing with it. 6j plus 15. All right. One more step and I'm done. Actually, 2 more steps. Ellie?
Subtract 81 from both sides.
You did the same thing before, right? If I subtract the 81, everything's on the same side.
So
Catherine, what do I do now? I want to get that 6j by itself. I don't want any other numbers on that side with it. Subtract 15. Good job. Subtract 15 from what number on the left-hand side, Catherine? So So I'm gonna get, what is it gonna be? 66. Equals 6J. Laura, last step is gonna be what?
Dividing 6 by both.
Divide by 6. J equals what?
11.
So I just solved for Jackie. I'm gonna scroll back up. Jackie equals 11. Now again, if I just read what it says, substitute letter you solve for into row 1 equation. Who did I just solve for? Jackie was what letter? J. Here's my row 1 equation. Again, don't go back to the original. Go back to what you rearranged, because what you rearranged already has a variable by itself. All right? So what am I going to write now, knowing what I know about Jackie? It's going to be, what am I going to write? M equals 78. I just solved for J, so 78
Minus 11.
minus 11. Good to see. M equals, what do I get? 67. So Megan is 67. Check. If I scroll back up, this is Mr. Hager already typed in our equations. Equation 1. Again, you want to this one we had to rearrange. When you write in your equation 1, if it says the sum, again, if it says the sum of their ages, that means that you're gonna have to rearrange, because you're taking your 2 single variables and adding them together. All right. Make sure, hold on to those notes, because tomorrow for the warm-up, we'll either do the extra example, or we'll do the example 2 as the warm-up. To give you guys a little bit of practice, then you'll already have this number. All right? Stop packing up, because you're still going to have time. What I tell you next is very important. All right? Homework, I think there's four problems. This is the couple important things come up here. Our test is on Wednesday this week. All right? Our test is on Wednesday. The reason being is the sophomores have MCAS next week. We do like a review day for like 30 or 40 of the sophomores that are taking it next week, and I'm one of the people that does it. So that means I won't be in class. It's on Thursday, so I wouldn't be in class. So the people I take out the test, I wouldn't be able to do that. I have to find somebody else, and I don't want to do that. And the way things are lined up this week, we'll be able to do the test on Wednesday, because tomorrow's the only day of new stuff. All right? Because the test was going to be Thursday, because we moved it up a day, Mr. Hager and I talked, you will be allowed to use your notes on this week's test. All right? Notes, homework, whatever's in your notebook, you can use it. All right? Whatever's in your notebook, you'll be able to use on the test this week. There'll be no reference sheet. You won't need it because you can use your notes. All right? Tomorrow night's homework will still be a mix of the stuff we did today and the mixture problems we do tomorrow. But you will be able to use your notes on the test on Wednesday. All right? I won't be in class on Thursday because I'm doing the MCAS review for ELA. We're going to have you guys do an MCAS problem. All right, the MCAS problem, it'll be like a system word problem that we've been doing this week. And also there'll be like an online assignment from the Big Ideas Math you'll have to work on. It'll kind of be a review. Make sure you bring your Chromebooks on Thursday, and they are charged, so you can use them. All right? No class on Friday. We won't see you guys on Friday. The periods are 3, 4, 7, 9. All right? I think you guys will still have one more week of academics left, right? You'll still have one after this week. You still have one more academic week for third grade. So next academic week will be the last one for third.